Hello everyone, myself Ankita Verma and I am here just to teach you guys chemistry because our aim is sharing is caring. So I'm here just to teach a very interesting topic that is chemical reactivity according to NCEA walkthrough guide. So this topic is related to level 2. So let's start. Take your pen and copy and just start the discussion. So first of all, there is a very interesting topic that is rates of reaction. So before studying about the reactions, you must know that which kind of reaction we are studying. So the main thing is some reactions are slow, some are fast. All these things depends explain the rate of reaction. So first of all, as they explained, chemistry is all about chemical reactions where we start with a handful of reactants and end up with a smarting of product, where we start from a reactant and end up with a very interesting product. That is chemistry. So chemical reaction is defined as a chemical change. This they are saying just it's a chemical change that occurs when substances are transformed into something new. That is the reaction, chemical reaction, how it happens. So this all comes just on the basis of rate of reaction. Some reactions are occur with the blink of eye, and some takes a very long time. For example, the very fast reaction is, for example, that is the neutralization. When an acid and base reacts with each other, that is a neutralization reaction, and it occurs within few seconds. Whereas uh, rusting of iron is a reaction which is the example of very slow reaction. So all those things explains the rate of reaction. But we must know about the idea of the collision theory before studying the rate of the reaction. So the very first and important thing which we have to discuss in this chapter is collision theory and how it relates with the rate of reaction. And the second thing is activation energy. Third one is effect of different kind of terms which affect the rate of the reaction, and the last but not the least that is catalyst. Okay, so let's start with the collision theory. So students, what do you mean by collision? Collision is something like reactants are coming, combine, and there is a crash, bang. That is the collision theory. But why we are studying collision theory in chemistry? The reason is the particle in a reaction are like mindless drones. They are just coming from this side, this side, this side, this side. They are mindless, aimlessly roaming around inside the container. They are just striking with the walls of the container and with each other. So this is the collision. But why this collision occurs and how it is useful for us? So the reason is where we are going, they don't even know. There is a very interesting term that is number of collisions are occur, but we are dealing with the successful collisions only. So successful collisions between the particle gives a product. Otherwise, they are just reacting from this side to this side. If there is no successive collision, then it is not useful for us. Okay, so the thing is, the overall rate of the reaction is impacted by the frequency of collisions. Frequency of collisions, or we can say that the collisions that are successful for us. The frequency of collision means the number of collisions occur in 1 second. For example, if in any reaction the number of collision in 1 second is like 1,000, and in another reaction the number of collision in 1 second is 500. So for us, the useful and the very fast reaction is that reaction in which number of collision is 1,000. Okay, but we have to take care about the successive collisions. So they are saying due to the collision, we are just giving the name to this theory is collision theory. So there are some questions. Stop and check these basic questions. So next is, if you know about the idea of collision theory, then what is the activation energy? What is the activation energy? So they are explaining chemical reactions are a bit like this. They need a push in the right direction to get the party started. Okay, so for example, you are going to a party and you are not interested to attend that party. Uh, I'm coming and I'm explaining that in the party there are a lot of games and just we are enjoying, and definitely we will enjoy. Just go for it. So that particular statement gives you activation. Okay, I'll attend that party. That's good. That's good for me. It means I'm coming with the activation energy, which gives you energy, and then you are ready to react. That is the main purpose of this activation energy, right? So activation energy is the barrier that stops the kids from dancing. uh, all chemical reaction need a bit of push, means the motivation, and that motivation is activation energy. For example, one more example is there. You are capable of doing something. For example, you are just a very good musician. Okay, you're a very good musician, and you are at a party, and no one is forcing you to play piano. But suddenly I'm coming in the party and I'm saying, go for it. And that particular statement gives you activation, that it needs a push. So that is the activation energy. So this is the diagram, or we can say that graph. Reactant A and reactant B, normally they are just staying, and this is the activation energy. Activation energy means that push. So we are giving the platform to them where they can react. One more example is there, that is, you are a very good singer, but you need a platform, and YouTube gives that platform to you. You are recording your music, and then there, you are just like, you become viral within a day. So that particular platform is activation energy. So it gives the product. So you can check it over there. Particles need a push in energy to react, that is activation energy. So now the question arises, that what do you mean by concentration? Why we are discussing these terms? Because the rate of the reaction depends upon following factors. The very first factor is concentration of the reactant. So check it over there. Increasing concentration, increasing the rate of reaction. For example, we are having only little bit molecules and we are saying the reaction is very slow. But if we are taking a lot of concentration, the reaction rate becomes fast. Fine. So the rate of the reaction depends upon the concentration of the reactant. So next thing is, the very good example is, think of walking around the busy mall around Christmas time. It's become very easy to bump it into the people as you move around. So this is the example where we are just saying, by increasing the concentration, what happens? By increasing the concentration, number of collision, that is frequency, increases. If the frequency increases, then the rate of reaction also increases. Fine. The next thing is, decreasing concentration has opposite effect and decreases rate of the reaction. So as the concentration decreases, as we can say that beginning of the reaction, the concentration of reactant is very high. By the end of the reaction, the concentration of product becomes high. So this is the effect of concentration on the rate of the reaction. So you must be careful about the concentration. Okay. So the next is defining the surface area. That is the point. Second point, that is surface area also affects the rate of the reaction. But how? Okay, so you have a sugar and you have to mix the sugar into water. As the surface area of sugar is like that in a cubic form, so you need a spoon to crush that. It means that reaction rate becomes slow. Another example, like of the same sugar, but you have that sugar in the powdered form. By the powdered form, you just take a spoon of sugar and just add it into the water. It means that happens very easily. So as surface area increases, the rate of the reaction also changes. It means we can say that the surface area also affects the rate of the reaction. If some chemicals are in the powdered form, then it is easily to dissolve them. It is very easy to dissolve them. So increasing surface area always increases the rate. Uh, One more example is you are going for barbecue and you are having a log of wood, but another side your friend has small little woods. That is very easy to burn them as compared to the big log. So that is the very common example. Third thing is, first you must know about the concentration. Second is surface area, and third one is temperature. So I don't think so that you are not able to understand the thing that is temperature. So temperature is something like as we increase the temperature, the number of collision increases due to which the rate of reaction also affects. So temperature always increases the rate of reaction. Uh, think about any solution of sugar. The very common example. If you have boiled water, it is very easy to dissolve that sugar into it. So low temperature and high temperature. What is the difference? Molecules are colliding like normal rate. As we are heating them, they are colliding at a faster rate. So we can say that temperature increases what? Temperature increases kinetic energy because they can. Kinetic energy means motion. They are in motion now. And secondly, it affects on the activation energy as well. Okay, so what is kinetic energy mechanism and what is kinetic energy? If you are discussing about kinetic energy, so it is only about the motion. The more heat is there, the faster the particles move. If the particles are moving faster, it means the number of collision increases. If the number of collision increases, it means rate of correction also affects. Think about it. Kinetic energy is just the motion. It means the particles are in motion. So next one is activation energy is mechanism. As we have already discussed in the last slide, that activation energy is something that needs to push the molecules. As we increase the temperature, it also increases. Last but not the least, that is catalyst. How catalyst affect the rate of the reaction? What is catalyst? You must know about this thing that someone who is not taking part of the reaction, who is not part of the reaction but affects to the reaction, that is catalyst. Catalyst is something which affects the rate of the reaction without taking part in the reaction. So catalysts are special molecules which increase the rate of the reaction without being used up in the reaction themselves. So catalysts are very important. It increases the rate of reaction. Due to the presence of catalyst, reaction rate becomes faster. And I am having one example of catalyst. That is catalyst. What do you mean by catalyst? So the example is you are studying in class level 2, but your parents are not. They are just you motivating you. They are just providing you the different books and inspiration, but they are not taking part in that particular class. Okay, they are not in the class, so they are playing the role of catalyst without being part of the class, but they are motivating you to study. So that is the role of catalyst in the reaction. So here it is. These are the two graphs. We can explain it. For example, this is the reactant and this is the high activation energy barrier, and then it forms the product. What is the role of catalyst? If we are adding the catalyst, then it lowers the activation energy barrier. It means, for example, 3 to 4 people are moving to the Mount Everest and they are not having the energy drink, then only one can climb over there. Whereas if the activation energy is low, four of them can give the product. Okay, so this is the role of catalyst in the collision theory. So all these questions are stop and check. So this is the example of chemical reactivity, chemistry, NCEA walkthrough guide. So you must know about the rate of the reaction, collision theory, activation energy, concentration, defining surface area, temperature and kinetic energy mechanism. All these things are there. I hope you all are fit and fine. So our motive is just sharing is caring. So kindly support us and thank you. I hope you all are fit and fine. Uh, Thank you for watching us.